In the first part of this video on graphical user interfaces and event handling, we will explain how to create a window and add components such as buttons and labels, and how to define layout managers that specify how those components will be arranged. In addition, we will use several simple examples of programs that create windows. Until now, all the program examples that we have studied have performed input-output on the command line or with files. We have begun with that approach because it is simpler. But any user of programs today knows that commercial programs use a graphical user interface. To create a program that uses a GUI, it is necessary to create a new window, or what Java refers to as a frame. The approach that we plan to use in all of our examples is to extend the JFrame class. Keep in mind that another approach is to use composition rather than inheritance. With composition, we would instead include an instance variable of type JFrame in our class. This is one case where the choice between inheritance and composition is not clear-cut. In all of the program examples that follow, there is another difference from the approach that we have used in previous examples. In the main method of these programs, we will instantiate an object of the class containing main. In previous examples, the methods in the main class only instantiated objects of other classes. One reason for this new approach is that the main method of all of these programs will be very short. Moreover, the control flow of GUI programs is quite different. Unlike all the previous programs where the first line of main was the first line of the program executed and the last line of main was the last line executed, main no longer has that same function. After it creates the window, it calls a method to make that window visible, and then it no longer has any role in the remaining execution of the program. In the earliest versions of Java, the classes required to create GUIs were contained in the package java.awt. In version 1.2, the JavaX Swing package was added. Although Swing is built on top of AWT, its components are lighter weight. We will see that there are still some classes in the original AWT package that we will need. The Windows 1 class illustrates a very simple program that produces a window with a name in the bar at the top of the window. One of the first lines of this program is the import statement that imports the package javax.swing, which contains the classes we need to create the GUI. Recall that using the import statement allows us to refer to the names of the classes in that package without prepending them with the package name. We adopt the practice of using the wildcard asterisk symbol to import all the classes. Some programmers prefer the style of never using wildcards. Many development environments like NetBeans will automatically add the import statements if you don't include them. We have taken the approach of extending the predefined JFrame class. Another alternative would have been an instance variable of type JFrame instead. Next, notice that in the constructor, we must first call the constructor of the superclass JFrame and pass to it the string that we wish to be displayed in the bar at the top of the window. Then we must set the size of the window by specifying the width and height in pixels, and finally indicate the default close option. If we don't specify the close option to exit, the program remains running after the window is closed, which is something that we generally only want if there are multiple windows. In the main method, we instantiate an object of the class Windows 1 and then call the setVisible method so that it becomes visible. The setVisible method should never be called in the constructor. It is important that it be called once the window object is fully created. Okay, so now let's run the program. Notice that an empty window is displayed that contains the string "just a window" in the bar at the top. When we close the window, the program will terminate. Of course, an empty window is not very useful, so we need to add some components to it. Let's consider several of the most commonly used GUI components. The first is a label. We create labels by specifying the string that they will contain. Although they can be used for many purposes, they are most commonly placed aside text fields to describe what those fields contain. Text fields can be used to supply input to a program and also to display output. When a text field is intended for output, we generally make the text field uneditable. Buttons are used to initiate action. We will need to wait until we discuss event handling to see how to associate actions with a particular button. The term radio button is really a metaphor for the mechanical buttons that were on car radios before the mid-1980s. The way they behaved was when any button was pushed in, the button currently in would pop out, so only one button could be selected at a time. GUI radio buttons are used for the same purpose. When we wish to provide a list of choices where only one of them can be selected. Like radio buttons, checkboxes are used to provide the user choices, but unlike radio buttons, they allow more than one to be selected at a time. When constructing a GUI, the components must be added to a frame or other container, such as panels, which we will discuss in Part 2. Our next example illustrates adding some GUI components to the window. It contains all of the same code from the previous example, but one difference is that we are now using a layout manager. So we have imported both Java AWT and Java Xswing. We will explain the role of layout manager shortly. Before adding the components, we called the method setLayout, passing to it an object of the flowLayout class. Next, we add several component objects to the window. Notice that the add method of JFrame is used for that purpose. In this example, we never need to again refer to these objects, so we have created anonymous objects in each case. Notice the main method remains the same as it will in all of these examples. Let's run this program. Observe that the components have been added left to right, top to bottom, in the order that we specified. Watch what occurs when the window is resized. The behavior was the result of the fact that we specified a flow layout. Keep in mind that in none of these examples will the GUI respond to our interaction. In other words, clicking the button at this point has no effect. Now we will explain the role of layout managers in greater detail. If you have worked with web pages, you know that the type of HTML tags that are used influence how the web browser renders the page when the window is resized. In much the same way, the type of layout manager chosen determines what happens when the window is resized. Let's consider three of the simplest layout managers. The first is flow layout, which is what we saw in the previous example. It arranges the components like text would be arranged, left to right and then top to bottom. Grid layout is another simple layout manager. As the name suggests, it allows us to add components to the cells of a grid. When we create a grid layout manager, we need to specify the number of rows and columns. Border layout allows the components to be added along each of 4 borders: top, bottom, left, and right, as well as the center. In Part 2, we will discuss nesting panels inside frames. Both frames and panels are considered to be containers. Each container typically has a defined layout manager. This example illustrates the use of the Grid Layout Manager. It creates a GUI for a calculator keypad. When the Grid Layout Manager is instantiated, we specify 4 rows and 3 columns. The other 2 values represent the horizontal and vertical gaps between the cells. As always, that information can be obtained by examining the Java API provided at Oracle's website, which is the definitive Java language reference. Notice that we have highlighted the definition of the constructor with 4 parameters. Returning to the GUI definition, this nested loop adds the keys 1 through 9 to the grid. The grid is populated in row major order, so the outer loop varies the row and the inner loop the column. The loop control variable of the outer loop, left key, contains the number in the leftmost key of each row. It begins at 7 and is decremented by 3 each time, so it will contain the values 7, 4, and then 1. To ensure that the key 0 is in the center, we first add a blank label to the leftmost cell on the last row before adding the 0 key. Let's run this program. And resize the window to watch how the Layout Manager modifies the GUI to accommodate the new size of the window. Again, keep in mind that clicking any of the buttons on the calculator has no effect.